In this tutorial, we'll learn how to build a custom face recognition in a real-time video streaming from a remote camera. One of the main goals of this tutorial is to show how easy it is to use Chrysalis Cloud to take a stream from a remote camera and then feed it into an existing AI solution. In our next few tutorials, we'll also show how to scale this solution to thousands of cameras and thousands of faces. Here we won't be focusing on how to develop your own facial recognition, but we'll use an existing one. The ChoochAI platform delivers a complete visual AI solutions, and we'll be using the custom face recognition. For this tutorial we chose Chooch platform because it's easy to use and we get a free API with 1,000 calls, so that should suffice for our needs. Here in the background we can see the end results we're trying to achieve. For development purposes, we use Adriana Lima's video on how she prepares for travel. Her face images are taken from a celebrity face recognition dataset. The link of that dataset you can find in the description below. We're aiming for a minimum amount of code with great results on the other end. Here we use OBS Studio to simulate a remote camera. If you would like to know more how to set up a OBS Studio with Chrysalis Cloud streaming servers, check out our previous tutorial in the description below. We lowered the quality of the video just a little bit in order to consume less bandwidth on our local network. Here's our Anaconda environment, and you can see we're using a couple of standard imports, including the Chrysalis Cloud SDK at the bottom. Now we create the Anaconda environment, and then prepare a basic code to display the remote stream on our local computer. Since we already covered this in our previous tutorial, here we're just going to speed up through the connection setting up, environment setup, and how to display a video stream. Now let's run it just to check if everything is alright. We have to remember that we set up OBS Studio to stream at 5 frames per second, and we lowered the quality of the streaming video just a little bit. Yeah. Since we're streaming with 5 frames per second, we'd like to minimize the number of calls to ChoochAI, otherwise we'll be calling their API 5 times a second. Additionally, we'd like to call an API only when the face is detected on the screen. So to determine whether the face is on the screen or not, we'll use the Opencv's Cascade classifier. Now that won't tell us who it is that we see on the video stream or an individual image of the video stream, but it will tell us that there's a face present. There's a great tutorial from Computerfile on how the HAR feature-based Cascade classifier works, so I recommend you check that out if you're interested in the details. Let's switch back to Visual Studio. First, we need to download a pre-trained classifier from Opencv. And let's load it into our Python code. Opencv already contains many pre-trained classifiers for face, eyes, smile, and so on. We're using the one just for frontal face detection. Now that we have that loaded, let's do a function that will actually detect the faces, draw a little square around it, and return whether there's a face on the existing image or not. In order to run a Cascade classifier, we need to convert an image to grayscale, and then we can call the detect multiscale function, which takes in our case, 2 parameters. The first parameter is a scale factor. The closest to the one in the model is the best, so we have the approximate same sizes of images, and then the second one is minimum number of neighbors that need to be returned or found for successful face detection. You can check the size of the trained images in the XML file, their width and height, and in our case we use minimum 5 neighbors need to be found in order to get a positive match for a face. If you increase that number, you'll get more quality matches, but you might get less matches of faces. So here we go through all the detected faces, and we're gonna draw a rectangle on the image that comes from the camera. Now we can call our function and get our answer whether there's a face in the image or not. So our face in video function returns two parameters, image and the rectangle, if there is a face on it, and the Boolean value has face. In order to call a ChoochAI API, we'll need to convert the BGR image format, and that's why we made a copy above of the original image, since we want to send the image without a square drawn in it to a ChoochAI API. So here's the conversion. The Chrysalis Cloud SDK returns always a BGR format in NumPy array, so we need to convert that, and for that we use Pillow library. Let's try to run it and see the results. Now we need to enable the video, and there we go. The Chrysalis Cloud will wait until the video starts streaming and then offer the video. So it seems this works. Now all we have left to do is prepare ChoochAI API and call it from our Python code. We'd like to detect two faces, mine and Adriana Lima's face. Since we have custom data, we need to introduce Chooch to our data through something called Contextual Perceptions. So we go to Training tab and My Facial. We create a new perception. It's just the default, whatever it's suggested. And we can add a person here. So let's add Adriana Lima first. And I have a couple of images prepared from the before mentioned dataset. So they recommend to add at least 5 portrait images of that person. So let's add those images in. And we're gonna add a little bit more than 5. I just upload it. Okay, and then let's add another person into the same perception. It's gonna be my name. Let's add it in, add the images. And I'm gonna also add a little bit more than just 5. Just to balance out the beauty. Now the only thing left to do after this is uploaded, oh there we go, is to make a note of a model ID that we want to use with an API call. So in our case this is 1429. Now let's switch back to Visual Studio Code and make a note of that model ID in our code also. We're ready to check out Chooch's documentation on how to use their APIs. So as you can see, they have from the general algorithms to custom ones that you can train on their platform. And the one we're looking for is a custom facial recognition API. We can just simply copy paste this URL, and we need to change our key and a model ID afterwards. So let's just do that. There's also one import missing that I've forgotten before, and this is a requests library. Now we can define a function that will call the API, starting with the modification of the URL with our key and the model ID. Let's also modify the input parameter name so we know which image we're dealing with, since we have an image and the original image down below. So we want to get in the RGB image, so let's call that method with the JPEG image. which is converted from the original image. And the results should be a JSON. But let's first examine that JSON file and see what we get as a response so we can analyze it and parse it later. Since our video images are in memory, we're going to convert it into bytes and send it directly from the memory. And we're going to use bytes IO for that. Now Pillow allows us to save that bytes in JPEG format. And since we're dealing with an open file, we need to set the reference point to the beginning of the file also. Here we just post that image to URL and return the JSON data response. Now let's slow down for a bit and let's put a break here, so as the first moment the face is detected, we kill the program. And let's see what that gets us. Oh, we need to enable the video stream. There we go. And we got our response from ChoochAI. Let's see how it looks like. So you can already see the first face that was detected was Adriana Lima with a similarity 0.66. So the similarity goes from 0 to 1. We also have the coordinates, but we won't use those. We'll just use the person's name. And we won't be listening to other parameters in this response because we just want to have the nearest match of the face that is currently on the video. But in practice, you would probably need to modify that parameter or acknowledge that parameter at least. Now all we have to do is parse the response. That should be fairly easy, so we're just gonna fast forward through that part of the code here, and we'll return just a name out of that parse chooch response. So the last thing we want to do is call a parse chooch response function with a response parameter that we got from chooch, and we get a name out, and we need to also put that name onto the screen with the Opencv function put text, and of course we draw it on the image that already has a rectangle drawn on it if there's a face, and in this case, if we are in this section of the code, there was a face detected. So you need to note that the detected face here is different than from the face recognition that we call a ChoochAI for. As I mentioned at the beginning, the if has face part of this method will give us will call a ChoochAI only in case when we detect faces on the screen. And let's remove the break because we want to do that continuously. Since this is a video, I'd like to increase the recognition call to every 2 seconds. And since we're using Chrysalis Cloud SDK, we don't need to worry about video decoding. It's all taken care of for us. So let's see the final result. Let's switch on Adriana Lima's face. Nope. Now we got a little bug here for the font. Let's fix that. There we go. Let's see it again. There we go. This is calling the ChoochAI, and the ChoochAI is recognizing Adriana Lima's face. Now I have prepared my video camera from my laptop. Let's see what happens when I switch it. Okay, this works as expected. So with OBS Studio, I can go back and forth from one video to another to see the change in the results, and we can see the ChoochAI recognizes that there are 2 different faces. If I switch back, I get my name displayed on the screen. With slight modifications to our code, we could easily make it work with Chooch's pre-trained perceptrons such as image classification, object recognition, and even text recognition. I encourage you to explore the existing and pre-trained perceptrons and try to create your own, as integration is very simple. This concludes our tutorial. Visit us at chriscloud.com to create a Chrysalis streaming server, and you can subscribe to our YouTube channel in order to receive notifications on our next tutorials, where we will explore in a bit more detail how face recognition works. Alongside with that, we'll also check how to scale this solution to thousands of cameras and thousands of faces.